Yeah, so we're doing the one way within subjects ANOVA and then the mixed ANOVA. And which one of those did you not do?
We did the mixed via Skype.
Yeah.
It was kind of different.
Very
Maybe
short.
we should go through everything.
Okay. Cool. So yeah, we'll go through everything. We're bringing in a lot of the same ideas, but a new thing is the idea of sphericity for the assumptions. How do you conceptualize that? Yeah.
Like a beach ball?
Exactly, yeah. Because that's one of the hardest things for me that I've tried to understand. And it comes in within subjects ANOVA. So the homogeneity of covariance. What does that mean to you?
The covariances are the same-ish.
Yeah. So we have homogeneity of variance versus homogeneity of covariance. So homogeneity of variance is for between subjects. So we're talking about whether or not these different variables vary similarly, kind of. And then homogeneity of covariance is saying within subjects, do these have a similar variance because they're related to one another?
Like on different levels of the IV?
Yeah, and however they're connected, like within subjects. So that's kind of how I think of it. Like, I kind of imagine like two pairs for variance, like together, holding hands. You know.
Why wasn't it called that for like the within or paired samples t-test?
What do you mean?
Like within subjects design for t-test, it's still just called homogeneity of variance, even though they're paired. So what's the
Oh,
difference?
good point. Ooh, see, that's...
I'm sorry, I
stumped
Well,
me.
don't you still need homogeneity of variance as well as sphericity?
Not for the one way within subjects ANOVA.
So are you saying that sphericity is homogeneity of covariance?
Yes.
Okay.
Mm-hmm. I don't know.
Okay.
So if... Actually, I'm so sorry, you guys. I did not upload any of the stuff, so I'm going to do that really quickly. I'm really sorry. I just realized that. The week off really did me in. So... Who wants to read the example on page... Do you have it? Do you want to read this example? Mm-hmm.
This is within subjects ANOVA. Studying nine clients in treatment for migraine headaches, researchers were interested in determining whether headache levels change across 5 weeks of treatment. 9 migraine sufferers were recruited and were asked to record the frequency and duration of their migraine headaches over a course of 5 weeks. Each week, each subject received the treatment. The ANOVA factor is week. The DV is the duration, hours per week of headaches.
Cool. How do we conceptualize why is it within subjects and what are we looking at? What are the variables that we have here? Mm-hmm. What is the DV?
Well, they said the DV was the duration of hours per week of migraine.
That maybe is the treatments, whatever treatment they're doing.
Mm-hmm. Okay. I'm really sorry, guys. I should have done this earlier.
We're dragging you so hard right
We're still gonna get out early. It's gonna be great.
So you're asking why it's a one-way?
Yeah. Just kind of setting up the example. What is another example that you'd use a one-way ANOVA? Like, what's another research design that you would use it for?
And you have multiple factors of the independent variable, so I guess it's a one way because they might be using multiple types of treatment methods.
Like different medications.
Just like one IV, but more than 2 levels to it.
Mm-hmm.
With one dependent variable, so another example would be
So that could be like a medication at different dosages.
Mm-hmm.
Or like 2 depression medications and 1 placebo.
And everyone gets one of them at some point. Yeah.
Oh, everyone would get
Yeah, so, yeah, because it would, within subjects, it would mean that, like,
one. Oh, right.
that they're connected.
Okay.
So, yeah, it can be, like, the same person, based on time, different medications.
So that's a bad example, because that wouldn't happen.
Yeah. Or like if it's different like doses of medication, it could be like the same people at different levels of the medication.
wait, so this one
Like
is a
starting off
within
at, like 10
subjects?
milligrams and then
Yeah.
like 60 or something.
That'd be true. I don't think that happens.
Okay.
So as
That's
in,
how
Oh, really?
a lot of medications that's how
Cool.
they start to go on medication.
Everything's there, so we
Oh,
can
okay.
open the instructions.
Yeah.
And some people are affected by like say like depression medication or
So-
like pain medication.
so it's
Some
the
people
same
can
that like
have, like
for every
10 or
week that
20
they come in,
milligrams,
they
and
would
it helps
get
Mhm.
like
versus,
a
like,
different
some other people need
type of
60.
treatment.
Right.
But each
Yeah.
participant
Yeah.
will receive
So that's
each
why
type of
study
treatment.
Yeah.
would be good.
And so
Okay.
sometimes they, like, switch. That's, like, another way to make sure that the placebo and, like, whatever treatment group aren't inherently different, is that they get, like, the same, right? Yeah, so there's a lot of different ways that can come in within subjects ANOVA, and a lot of it is, like, kind of treatment-based, that type of thing. One-to-one matching of participants across all of the groups. So that another thing is, like, with, like, I don't think we talked about it as much with the paired samples t-test, but you can also do, like, they give the example of family members. So if there's multiple family members, but you want to connect their responses, you would use the within subjects. Or, like, yeah. And it's kind of hard to conceptualize, like, a study where you would use that, but it's very specific. But yeah, so each participant serves as his or her own control across levels, so that's the treatment, and everyone gets all of the treatments. Repeated measures for time, so there's a lot of different ways to do it. And so another just example with the ANOVA is that it's practically the same as the paired samples t-test, but now we have more than 2 levels, so it just kind of changes the way we looked at the data. So we're going to have, like, our F statistic that is omnibus and looks around the whole analysis, as opposed to just the t-test that lets us know that there is or isn't a difference. So in this case, we don't have, because we have more than 2 groups, we don't have statistical notation for the hope null. So it's just in the population, all levels of the factor have equal means. Yeah, so just whatever the level is, all of them have equal means. And then alternative, there is some inequality because we don't know where the inequality is. So independence of observations, because within, like, in these packets, they change up the wording a lot with these independence within subject, or between groups, within groups. So it gets kind of confusing, but all this is saying that there is no connections between the paired observations inherently, besides, how do they put it? So besides,
Systematically
yeah.
linked.
They're not systematically linked besides what's required by the design. So, like, the only thing that is connected between these observations is that factor. So the time, like, it's the same person, or they're in the same family. That's all that kind of means, and that's another, like, take it on faith thing because it's not in the design necessarily. Normality, we're going to do that on the DV once more, so it's just the same type of thing. Much the same. Yes.
So is it on the raw scores or differences? You know, like we were doing within subjects T, we would be doing the differences between them.
So we're not doing differences here because there's two or more. I think what you do is, oh God.
Technically, it is the differences because an F ratio is the ratio of the mean differences over the error of the means. So,
I know, but if you were going to perform descriptives to determine normal distribution, if you did that for within subjects T, you would take the difference of the paired scores. So we just do it on the raw scores
Yes.
of the factor lines?
Oh, okay, so for looking down here, so for normality, we're going to look at the DV. So it says you'll put over the DV to the dependent list, and then it'll pop out that way. Does that make sense? So there's no factoring, like factor grouping.
So, independence of observation is the same as independence within group design?
Yes,
Okay.
I believe so.
so it is
Okay. Oh, okay. So then at the top, so if the normality assumption of the one way within subjects ANOVA is violated, the central limit theorem cannot be applied to satisfy the assumption. So then we would use an alternative test, non-parametric, and that would be the Friedman's test. One of those is that we would use. So just keep that in mind that normally, if it was violated, like you wouldn't want to use this test. But for the homework and PE, if you find that, just do it anyway.
Do they ever actually teach us any non-parametric tests, or is that something we just
Yes,
figure out
we
on
do.
our own?
We do later in the year. It's kind of lumped in, I think, at the end. But yeah. Anyway, okay. So then for sphericity, so homogeneity of covariance. That is an output that comes when we run the ANOVA. And so to do this, we look at two different statistics. Honestly, let's do the example, go back to the example, and then we can run it, and then I can show you what it looks like, because it's a little...
So conceptually, for that example of the family member, like homogeneity of variance would be all the mothers in the population have the same variance of answers, all the fathers, all the brothers, and then covariance would be all the family members linked together have the same.
Yes.
Okay.
That's a great way to put it. That's so great job.
Can you say it again?
The homogeneity of variance would be that all the mothers in the population have homogeneity of variance, all the fathers compared to each other have homogeneity of variance, all the brothers, all the sisters, and then the covariance would be that the way their results link up together compared to another family, the way that their results link up together, and all the families together have homogeneity of variance.
Cool. So if you go to Moodle and open the within ANOVA, we have the data here. And so we can practice doing the
My SPSS isn't working.
Oh no, I'm sorry. So we can run the normality just for shits and giggles. So we'll go to do explore, and so we'll put the weeks, all 5 to the dependent list, and so then that's how it'll come out. Oops. And we'll just do the same exact thing that we've been doing. Normality plots with tests, histogram. If you want to do the stem and leaf plot, you can do that too. And that's all we would do.
We're not putting person anywhere. We don't have to leave it.
Mm-mm. So then it'll come out with all of our normality stuff that we need.
Did we do?
Are you?
I'm trying to. I have to open it up.
Yeah. So all you do is before you would just have the one variable, but since it's with repeated measures, we have 5 different variables in SPSS for the variable of time.
Mm-hmm.
So you would just put all 5 of those variables into the dependent list for the normality, so they pop out every single one of them. We can let me know when you're there because we can move on. But
if you have to get the normality for each week, wouldn't each week be a level or a factor of the dependent variable?
yeah. So just oh god. Yes, yeah. Yeah, so you're just comparing the different, you're doing it for each level of the dependent variable.
It's opening.
Okay.
So there doesn't need to be one level of dependent variable.
There needs to be one DP.
But it can have multiple levels.
Okay. It's open. So we go to
Analyze, descriptive, or descriptive, and then explore, and then put each week over to the dependent list, and then click the stuff that you usually do, and then it'll pop out.
And the person is the factor?
No, don't put the person in.
Oh, Normality tests?
Okay, so then next to run the within subjects ANOVA, we're going to go to general linear model. And then repeated measures, because we have repeated measures. So we're going to call the factor name week, so we can consolidate the 5 different things that we have. Our number of levels are 5. So adding that. Is that correct? Define. And then so what we'll do is we'll put over each one into the factor that we have here. And then we'll go to plots, and we're going to put week over to the horizontal axis, and then add. Continue. Go down to options, and we want descriptive stats, estimates of effect size, and then that should be good.
We don't have to click the homogeneity test ones.
No. I'm gonna do it to see what pops out.
We don't need the means because we already did
Mm-hmm. Yeah. Continue paste. Oh, okay. Sorry. Woo! Dang it. It has like randomly syntax directions in here. Why? I don't know why. Okay, so anyways, we did all that. Should be ready. Oops. Okay, so then okay. Okay, then we have a lot of stuff going on here. Okay, so what we're going to look at for the homogeneity of covariance is the sphericity. This Mauchly's test of sphericity. So, okay, this is kind of like a decision tree type thing that we have going on here. And so this is just like similar to the other assumptions that we've been doing. And so okay, so again, we're going to look, and if you look down here, it says sphericity assumed, and it has these different ones right here. So if our Mauchly's whatever test is non-significant, then we can assume sphericity has been met, right? And so then, as long as it's not significant, we can just move on and use the sphericity assumed rho for our F statistics, and like move on with life. But
So is the significance cutoff just 0.05?
mm-hmm. Yeah.
But so normality wasn't met, which like we're gonna do it anyway. But then we wouldn't use this test at all.
It's not the same as homogeneity variance. We would still use it.
Okay. So normality doesn't really matter as much.
It always matters.
But these data are not normal.
Yeah.
The sample's too small.
Mm-hmm.
You can apply central limit here.
Mm-hmm.
And week 5 is significant for
Mm-hmm.
normality. And if you look at the graphs, they all show patterns.
Yeah.
So
So it's not a really good sample because every group has 9 people.
Mhm.
So it's like not that great.
So like in real life, you would want to use a non-parametric test.
Mm-hmm.
You're saying the only normality is for the week 5, right? And the other ones are not normal.
No, vice versa. Only week 5 is non-normal.
Oh.
The test of normality is significant. But if you look at the graphs for all of them, they all show some sort of skewness.
Is normality and Levine's being opposite? I was gonna say.
No, it means
Right? Like if it's not,
yeah,
then it's significant. Or then it's normal.
right.
Which is the same
If
for the
it's not
KS.
significant.
If it's not significant, it's normal.
Right, which is the same for
So it's like
KS.
it means, yeah.
Right.
In this case, there's your answer to by the way. It didn't bother to run homogeneity because there were no between elements. There's an error at the top of that. So don't check that box.
It's like when the post hoc tests don't show up because there's
Because
Toast to be
too many
During the fine.
great time to learn.
What are these multivariate tests that show up at the top? Is that not important?
That is not something that we've learned or will learn.
Oh.
So I'm not sure, honestly.
Roy's largest root. Sounds like a bad tourist attraction. That's right there past the corn maze. It's Roy's largest root.
Okay, so Sorry, I was just making sure that I was doing this right. But yeah, so it's the same as all the other assumptions, is where we want it to be non-significant, so we can use severity assumed. But so let's say that this is significant. This is where like the decision tree comes in, kind of. So then we're going to look at the greenhouse geyser epsilon. And if you look at page 3 in here, it has a crib sheet for how to read the GG epsilon. So if, and it kind of has some ranges. So if it's closer to 1, you can use the sphericity assumed row. If GG is if it's closer to 0.75 but not below 0.75.
What is that handout that you're referring to?
It's the instruction manual.
Okay.
Yeah.
It's on
The lab
So-
5 speed 13 instructions.
Yes.
You said it's on the 3rd page though?
the fourth page.
Oh, fourth.
So this is new. She gave us these cutoffs because the crib sheet cutoffs are kind of really not clear. So we'll just go ahead and go with these. So we'll do sphericity assumed. So even if our Moxley's test is significant, and then we look at the GG and it's above 0.89, we'll still use the sphericity assumed line. But if it is in this range, we're going to use the HF row, so the Hunefeld row right here. And then below 0.75, we'll use the GG row, or yeah, we'll use the GG row. So that's a little bit clearer, like cutoff points to use for that, because it's kind of subjective right here.
So the values given under the GG and the HF, those are F values, not P values?
These ones?
Yeah.
These are epsilon, so this is like a different value statistic entirely.
So when it says F, it's talking about the table below that we're going to look at right now?
Yeah, so it's telling you which one you're gonna use.
Okay.
So another thing is that the only difference between like these different ones is the DF. As you'll see, so the F is like the same and the significance is the same. It's kind of just this will be the difference. Yeah. Does that make sense? So then that's how you do sphericity.
So the GG is only used to determine what kind of thing you're looking at.
Mm-hmm. So it's if you get a non or a significant Moxley's. So if it's NS, if it's NS, you'll go there. If it's SIG, opposite. SIG, you'll go there. If it's NS, sphericity assumed. Yeah?
Mm-hmm.
Cool. So then we'll look at interpreting the results. So, okay, sorry. Anyway, so we're going to use the sphericity assumed row. So, memorizing what you need to report the results is pretty much the same as the other ANOVAs that we've been doing. So you're going to do the F statistic, you're going to do the DF, and you have the statistic, or what do you call this one? The statistic one and then the error. So we're going to do both of those, and then p-value, and we're going to say whether or not it's significant, whether or not we reject or fail to reject the null, and then kind of make a concluding statement about our hypothesis in terms of the design of the study. So the result is significant. We can reject the null hypothesis and conclude that there is some inequality between the groups' weeks of treatments in the population.
In the example in the instruction, they say that because the n is so small, they take into account that interspersity and look at the GG.
Yeah.
Anyway.
But the thing that's what I was looking at too, but in the answers they still use the sphericity assumed rho.
I mean, then they say since it is not significant anyway, for simplicity they just use sphericity assumed. So what? They just put it in there to just be like, look at this too.
Right? To be confusing. Yeah. So who knows? I don't know who wrote this.
So in this case, it's maybe F432.
Yeah. Okay, and then so we also have our effect size, which we use the eta squared.
Where's there 432? 4. Okay. Yeah.
Woo. So yeah, we're gonna use the eta squared once again. So then we have 0.875 for eta squared, and that tells us that 87.5 of the variance in duration of headaches is accounted for by the week of treatment in the sample. So that's our effect size. So then because we have more than 2 levels of the week, we're going to look at the post hoc test to see where the differences lie. So we're going to go back and run the post hoc test. So we're just going to do the same path. So general linear model, repeated measures, going here. Oh. How do we get that to work? That's what I was worried about.
Do you have to put like the person into the between subject factor? Yeah, that's how you do it.
Okay, cool.
I found it. That's on the button.
So yeah, so do the post hoc test. We're going to put between subjects factors, post hoc, put the person over, and then you can use whatever you like. Use your discretion. And then run it.
Why don't people always use Bonfrey?
Because there's differing reasons why.
Because they want to cheat, right?
Yeah.
I mean, essentially.
Yeah.
It says post hoc tests were not run.
I think it's the way that they have the variables set up. This is really confusing me right now. Okay, let's figure this out. Repeated measures, options. In the top left box, click the name of the within subject's factor. Okay, so go to options, click on week, and we'll do display means for. And then click on compare main effects. And then, okay. So it is important to have that. Okay, got it. So then that's how we do the post-hoc test for this.
I still didn't get it.
Can we go through
How did you get there again?
Yeah.
To the review.
Yeah, let me run it and see if anything happens. I think we need to take out the between subjects thing. So general linear model, take out the person.
Are you on repeated measure?
Take out the person between subjects factor, because actually that makes sense, because that's comparing each person, which is like too much. So then go to options, and then click over week, and then pick one of the compare main effects, and then pick one, and then
Is it the pairwise? Oh, okay.
Yeah. pairwise comparisons. So looking at this, we can see that the first week of treatment was significant differences between 3, 4, and 5, whereas it wasn't significant for week 2, between week 2. And there's just like a lot of comparisons there. So do you have any questions about that?
Could you repeat again what you saw as significant here?
Yep, so, comparing week 1 and 3, 1 and 4,
Okay.
1 and 5, 2 and 3, 2 and 4, and then those should be repeated.
Well, 3 and 4 and 3 and 5 are not
And
significant.
1 and 2.
Yeah, okay. 3, yeah.
So do you then have to do the simple effects?
What do you mean?
What did we do?
Isn't this the simple effect? The main
No.
effect would be.
No, because then for the final we had to do. Oh, but that was a multivariate. Okay, never mind.
I think that, yeah, that'll come up for the mixed ANOVA, kind of, but not,
Because we had to. Yeah, that was a mixed.
does that make sense, what we've done here tonight, right now? Because then we can move on to the mixed ANOVA. Yeah? So the mixed ANOVA is mixing between groups factors and within subjects factors. So that can get really messy sometimes, but we will persevere. And so, like the factorial ANOVA, we're going to have 2 different factors, 2 or more different factors, and we're going to have interaction effects as well. It's just that for this, we have between subjects and within subjects factors. So it can get a little tricky. So, yeah, so just this, like the same things that we've been talking about, gives the example of the within subjects being time, pre-test, post-test, follow-up, the between subjects factor being type of therapy, so it can really be anything. I don't think that they have more than 2 factors for any of the examples or homework or PE or anything, so we'll just stick to the 2x2, or the comparing 2 factors. So our null is going to be very similar to the factorial ANOVA. So in the population, all levels of the factor have equal marginal means. Same for the, so we just have to have the main effect for between subjects and within subjects. So factor 1, factor 2. And we're looking at the marginal means. Yeah.
So,
So for the last example, like they're using the same example now, they're just adding a treatment.
see if it settles down.
Mhm.
This is the big one.
Oh,
Yeah.
really?
Oh, really?
The big one.
But what?
Not for doing for all.
Me neither. Fudge. So yeah, and then we have our interaction effect. So in the population, the effect of each factor is consistent across the levels of the other factor. So yeah, bringing in the same types of ideas as the factorial ANOVA.
What is the like study example for this data? Like what are these things mean? What are we looking at?
Oh, sorry. We have not gotten there yet.
Okay.
But I think they are using the, yeah, so I'll just read it. So this is the design. So researchers were interested in whether or not there were differences on the amount of depression experienced depending on type of therapy that was received. The same 10 participants received psychoanalytic, Jungian, behavioral, and EFT therapy, and their depression levels were recorded before treatment, after treatment, and 1 month follow-up. So we have our between and our within factor. And so that's what we're looking at.
Wait, it said all 10 received the same treatment?
Yes.
So it's within?
Well, no, see, there's multiple treatments. See the treatment column there?
Yeah.
So there's 4 of those. And then,
But each person received all 4
Yeah.
treatments?
So
That's
person
something-
one,
Yeah.
So it's within?
it's both.
That's the within.
yeah, that's the,
And then the between
Mm-hmm.
is the time points of the
Okay.
between is between the treatments, right?
Yeah. Between is the treatments, and then within is the time.
Oh, okay.
Mm-hmm. Because classified participants among the types of treatment. Oh my gosh, that's confusing.
That just seems like within.
It does,
Right?
but I think the idea is that, oh my god.
Like, what would make it not between?
Well, no, see, 'cause they actually measured them at pre, post, and follow-up for every treatment.
Mm-hmm.
So,
And this is
the,
the first.
I mean, it looks to me like it would be riddled with confounds because
Yeah.
you're providing all 4 treatments.
Okay.
Yeah.
But so it's as though each individual is different after each treatment because they measure.
So, okay. It's not one pre-test, one post-test, and one follow-up.
Yeah.
It's one for
Each
each
time.
set of
Yeah.
type of therapy.
Yeah.
Okay.
And so they use this type of design for, like, it's hard, like, the reason why they do it is so that they can, like, get rid of factors like the order in which you do things sometimes, like doing, like, therapy first, medication second, and then, like, a placebo. They do it so, like, the order of things don't matter, or so that everyone kind of gets the same things. And so this is, like, yeah, like, kind of not a really good example of it. But it makes sense sometimes. Okay, so we have 4 assumptions. So this is because we have both within subjects and between subjects. We are going to combine a lot of the assumptions that we've been doing. So another thing that I think is really important for the assumptions is looking at our variables and, like, are these between subjects or within subjects? And based on that identification, we can kind of guess and figure out what assumptions we would need, because we know that for between subjects, we're going to need independence between groups and homogeneity of variance. For within subjects, we're going to need independence within the groups as well. So another thing also is independence within groups is going to be for, like, everyone, because you need independence within all the groups all the time.
And the only way to test that is the design. Or, like, you can't test that. You
Yeah.
have to trust.
Yeah,
Can
trusting.
saying like independence of observation encompass both, like, between and within?
I don't know.
Okay.
I don't know why it switches between observations and between and within,
I'll
honestly.
try not to get hung up on
Yeah, don't, yeah.
Yeah.
Because obviously the packets get really confusing, and so I'm like, is this an actual thing, or is it just this packet saying that?
that. Okay.
Okay, so also, looking at the packet, I just saw another factor about sphericity that they didn't mention in the first time that it's introduced. So for sphericity, it's only... Where is that?
I think it was number 6. Go up. Right there down. L4. Number 4. Is that what you were referring to?
Yes, sorry. So it says only when there are at least 3 levels of our within subjects factor. So that's the only time that sphericity comes in.
Which makes sense because there has to be more than 2 levels for it to even qualify for this test.
Yeah.
So what's the within subjects factor here?
The time
Okay.
of the depression measure.
So the pre-test, post-test follow-up? Okay.
So we have independence between and within groups, the normality, homogeneity variance, and the sphericity if it's applicable for the ANOVA, which it will be because there will be more than 2 levels probably. Sphericity referred to emotional sensation.
I'm still kind of confused about the between. So, for like a regular test with like one person taking 2 treatments and 1 measure, that would be within, right? Like for a t-test.
One treatment at 2 time points.
Like if one person is getting 2 different treatments.
One person is getting 2 different treatments. Okay.
And it's being measured by like the Beck's depression inventory.
So I think what it's, oh god, this is
That would be
really
within.
hard to wrap my brain around right now.
If it was like a longitudinal study, that would be between.
Yeah,
But since there's multiple measures, they're not just doing one thing, they're doing 4 different things, and it's longitudinal for all 4. That makes it within also, I think.
So, but okay, originally you said if it's longitudinal, it's between.
Right, okay, so if there wasn't 4 treatments, there was 1 treatment, but they were measuring it at 3 different time points. That would be between.
Oh.
But now everybody's doing every treatment, like there's 4 treatments now also, and they're also measuring it at multiple time points. So that would be the within component, I think.
Why would that first one be between?
Yeah.
It would, wait. Yeah, oh, okay, I flipped the 2.
Okay.
Sorry.
Okay.
I think what the example you gave with 2 treatments would be between, though, because the result they get on the first treatment is not linked to the result they get on the second treatment unless the treatments are linked. So then each
So if the
participant-
treatments are independent, then it's between, regardless of if it's just one sample person.
I think so. I think it makes more sense to
Yeah.
think of the example you're giving, but use time as what's linked. Like one treatment with a pre-test and a post-test, because then it matters that it's the same participant.
So the time is linked, which makes it within.
So is it like,
But the treatment is not linked, which makes it between.
If in that case there's only one treatment they're receiving, so there's nothing for it to be.
Right.
It's just the 2 time points matter because it's the same person that is.
Okay, that makes sense.
And
in between everybody gets the same treatment, within there's different, like different groups?
say it again.
Isn't within there's just different groups, and within there's different groups in between everybody gets the same treatment?
Between everybody would be getting different treatment.
Oh, yeah. But yeah, that's like the 2 factors, right? Everyone gets the same, or everyone gets.
Everyone gets either the same or everyone gets all of the treatment.
I think I just untaught myself.
Yeah.
This repeated measure stuff gets confusing. Okay.
Like in this example, with the
Okay.
The time makes it within
the time
because it's connected.
the time makes it within each treatment. So like the Jungians, they get a pre-test, a post-test, and a follow-up. So it matters that that person receives all 3 time points to measure that one treatment. That makes it within that one participant. And then each treatment is its own series of pre-test, post-test, follow-up, which makes it between. because then each person's set for each type of therapy can be, it doesn't really matter if that one person did all four. I mean, for the sake of the study, they're trying to be consistent and have each person receive all types of therapy. But it wouldn't really matter if each person received all types of therapy. That's what makes it between. They don't need
chances are you're probably going to be evaluating the treatment as a whole rather than an individual within.
Yeah. But the individual matters for the time because they need to receive the pre-test, the post-test, and the follow-up for that treatment set in order for it to mean something.
Yeah, so I think I'm trying to look up other examples to like make it a little bit more clear because it is hard because like they're getting all the same treatment, so it makes it seem like it's between subject or make it seem like it's within. But the idea is that if you didn't have the time factor, you would just be comparing the different types of treatment, right?
Okay.
So another, I have a different example that's kind of, it's comparing, so stress level, it's like employment, and they're unemployed people, and looking at their stress level. So they have their within subjects time, which is time, and so they do them at different levels. Whereas for the between subjects factor, they use age. So they're not connected at all. So it's young people, middle-aged, and older. And so that's a mixed ANOVA too. It's the same principle. I think it's just this specific design that is like really confusing to wrap your head around. Yeah.
I want to like see if it
makes
go
for it.
sense.
So that's another example. Another example is they're using the effect of exercise intensity on depression, taking into account differences in gender. So within subjects is going to be intensity, so high, medium, low, so every person gets those. And then the between subjects is the gender. Does that make sense? So it's just like a factor of the specific design being kind of iffy because it's kind of like they pool, even though they all get the same treatment, they kind of pool their answers together by the treatment group instead of like connecting the different ones.
I'm trying to like visualize it. I guess like what you're saying, Jordan, is if it was just like this, like measuring the type of treatment, that's between. Okay. I get it.
You do get it? Okay.
That's where it matters.
I think, okay, forgive me if I'm wrong, but if each person didn't go through the same treatment, like, or go through all treatments, it would still be a mixed ANOVA. Because you would still have the pre-test, post-test follow-up, and then the different types of treatment, right?
But you wouldn't have the same, like, sample size for each treatment.
Yes. Yeah. Yeah. That's why they do it. Yeah, so they just kind of added this weird factor where every participant goes through all of them, I think, for no reason.
It seems like it would control for confounds.
Yeah, so there's reasons, again, why they do these things. Okay. Are we on the same page?
Yes.
Okay, so we can go ahead and run it. So go to Analyze, General Linear Model, Repeated Measures. So we're going to do, our within subjects factor is time once again. And we have 3 levels. I'm going to add that. Define. So we have pre-test, post-test, and follow-up. Yep. And then we're going to put our treatment to the between subjects factor. We're going to go to plots. We're going to do the within subjects on the horizontal axis, and then treatment on separate lines. Add. Okay. Post hoc, we're going to put treatment over. Choose whatever you want. I'm going to do Bonferroni. We're going to go to options, descriptive stats, effect size, homogeneity tests. And then we're going to put time over because we want to have the post hoc test for time as well. But because it's repeated measures, we need to do it within the options thingy.
Why just time?
Yeah.
So
The other ones, that only functions on the within. The other one that you
Oh.
picked on the outside, and that's the between.
Okay.
Yep, I think that, and that's all.
And we're not looking at the interaction between treatment and time?
We are. It will pop out with the ANOVA. And that should have everything that we need, so we can do OK, run it. So we have a lot once more. Okay, where to begin? Let's look at the Mauchly's test just for good measure. So we see that it's significant. So what would we do?
The GG.
GG, and it's 0.79.
It's fine.
We would use the HF row for our F statistic. That's what we would do. Yeah.
Any time is significant.
Yes. Where's...
Why is there a red arrow pointing to time? Why do I have a red
It's just where you
when you click.
where your icon is.
Yeah.
Oh, really?
Mhm.
Yeah.
I have never
So,
noticed that.
Put the first arrows up and down and over.
So it has it, our F statistics broken up by within subjects and then between subjects effects. So whatever you want to look at first. So yeah, we see that time is significant. So we would report the F statistic as 130.633. Our DF would be 1.79, and then 64452. Result is significant. We can reject the null. Conclude that in the population there is some inequality between the marginal means of levels of time. So that's our time factor. So then we're going to go down and look at our between subjects factor of treatment. And we have the F statistic right here, DF 336, and then we find that it's not significant. So we would just say our conclusions about that.
Can we ignore the intercept?
Yes, because that's what we do.
Okay.
And so, yeah. Anyway. Wait, okay. So then, to do our interaction effect, we're going to go back up to the within subjects contrast because the within subjects factor is included within that. It would just be included in the within subjects effects. So looking at that, we can also see that that is not significant as well. So that's just saying that based on our results, that they just found that the time was the only thing that was significant to the results on depression. So that's corroborating the fact that different types of therapy, modes of therapy, kind of do the same things for people.
Mm-hmm.
So that kind of makes sense. And so for that, we would want to do our eta squared effect size, and so because we only had one for time, that's the only one that we would do. So 0.784, doing 78.4% of the variance, and the dV is that is not accounted for by the other effects is accounted for by time in the sample. Okay, so then we're going to look at the post-hoc test. So you remember that we ran it for both the between subjects and within subjects factors, but because we only had one of those significant, we're only going to look at the one. So we're going to look at the time. Yes. Wait, what?
Which is only within subject.
Yes, yeah. Because we see down here that for the treatment, there's like nothing there. So it's run anyway, but there's just nothing significant. So we can see that there's significant differences between time 1 and 2, time 1 and 3, and there's no significant difference between time 2 and 3. So that makes sense. So it's post-treatment and then follow-up. So that makes sense, and that's good for the outcomes. And that is a within subjects ANOVA. Yeah. Do you have any questions about that?
So the time, and just to interpret the results of this, it's saying that the time between the second and third time period are not that significant. Mm-hmm. So there's not much of a difference in treatment between those, but there's still a little bit of a difference.
Mm-hmm. Between times 2 and 3.
Yeah.
I think. Mm-hmm. But it's whether or not it's significant.
Right. I'm just thinking to apply this to the real world. So you could do therapy for half the amount of time and still get this almost the same results if you were to do therapy for the whole time.
Well, what do you mean?
Because the time period, between the first time point and the second time point, and then the second time point and third time point, let's say it's 1 month between each time point, right?
So for this design, they did pre-treatment, post-treatment, and then...
Oh, just kidding. I'm thinking of time as a different thing.
Yeah. No, but that would make sense.
Okay.
And they do that to check, how long is it effective? Is there a time when it bottles off? Yeah.
Okay.
So, and you can see between, so this graph is, putting it out for us. So it's saying that, there's a significant difference between 1 and 2 for all of them. And then it kind of branches off between them, but it's still not a significant difference before all of these. Behavioral, that's the best. Million, not so great. Yeah, let me see what the homework question is like. So, good news for the PE and the homework. They only are testing you on the mixed ANOVA. So we learned the one-way repeated measures, and that's good to know. But they're not going to be tested on it, or you're not going to be tested on it. So we can.
So we're only going to be tested on this type.
Yeah, because it's applying both of them together, so it's kind of giving you a break. So why don't I read the prompt from the homework and we can kind of talk about it for like a second? Because for next week, if you remember, so we're going to meet, whenever you guys get done with article, we're going to meet and talk about the homework for a little bit. Have any questions? If you have any questions before we take the PE, we can do it, and we can take as long for that as possible, or whatever you guys want, and then we can kind of take a break, and then we'll just start the PE again. So another thing was I saying? Oh yeah, so if you get, I would like to give you guys feedback on the homework since it'll be like all in one day, but if you're going to want that from me, like I need you to send it to me by Tuesday at noon so I can have time to look at it before the PE the next day. Does that make sense? So usually it would be due on midnight, but I'm kind of giving you the morning. I guess you guys aren't even here usually on Tuesday. But anyway, because I'll just need some time to look at it before I can do that. So if you turn it in past noon, like I won't be able to look at it probably. Okay, so the question is, so there were 179 participants in the sample. The participants were shown a short instructional slide presentation on the behavior of people in a group situation, and in particular, the various roles that group members often assume. Each role was identified by an animal, and each animal was shown in 2 slides, once in a cartoon sketch and once in a realistic picture. A random half of the participants saw the slides in black and white, while the other half saw the slides in color. After seeing the slides, so that's the different types of slides is the treatment. They are saying it's a treatment. The participants were tested on the material. The participants were tested again 4 weeks later and then tested for a final score 8 weeks after that. One purpose of the study was to learn whether memory differed depending on the mode of presentation, color, versus black and white slides. The second purpose of the study was to learn whether memory differed from time 1, 2, and 3. Oh my god. I remember this one. This is really hard.
So they see 2 different types of slides regardless, but it's whether they see it in color or in black and white that is the treatment.
Yeah.
And then the time points are the within subjects. Maybe for friends.
Oh, okay. I partly lied. Sorry, guys. But they ask you less questions about it. So for the homework, there's 2 different hypotheses for this design. So the first one is the repeated measures, and the second one is the mixed. Let me know if you have any questions about it.
So this next PE is a part one.
Oh, yeah.